Here we are in section 3.1 exercises, part C. Solve for numbers 1 through 8. Number 1. Here we have kind of a big looking one. It says to solve, but the x is just in one little place right in the middle. So we have to peel off everything that is around it in reverse order of how it's attached. Let's start from the middle. The x first hits the 3, and the 3x adds 4. Then the 3x plus 4 gets divided by 5. Then that result adds 2. Then that whole thing in the middle times by 5. So let's do that in reverse order. Opposite of times by 5 is divide by 5. So if we divide by 5 and divide by 5, this guy will cancel right here, and we're left with 3x plus 4 all over 5 plus 2. That 5 is gone, so we don't need the parentheses anymore. 65 divided by 5 is 13. Okay, what's the next outside one? Well, that plus 2 is hanging out over there. Let's get rid of him. What's the opposite of a plus 2? Minus 2. So when we minus 2, we now have 3x plus 4 all over 5 equals 13 minus 2 is 11. Okay, how can we get rid of this divided by 5? We do it by timesing by 5 onto both sides. And we now have 3x plus 4 equals, well, that 5 canceled, but on the other side we have 55. Good. Now we're down to something that's a lot nicer. We can subtract the 4, which is the opposite of add 4, so subtract 4 from both sides, and we get 3x equals 55 minus 54 is 51. And the last thing to get rid of is that 3. Divide by 3, and we get that x equals 17. Let's check our answer on that one. Oh yes, x equals 17. All right, number 2 looks like a big one again. We can do this the same way. We're trying to find this x in the middle. So notice that the x first times by the negative 2. So that means dividing by the negative 2 will be the last thing we do. Then it adds 8, and that whole thing divides by 5, minus 3, and then that whole thing times by 3, and then adds 17. So in reverse order, we're going to subtract 17 on both sides. Make sure it's done on both sides. On the left-hand side, it just cancels, but on the right-hand side will yield a different result. So we get 3 parentheses negative 2x plus 8 all over 5. Ooh, big problem. Minus 3 equals 20 minus 17 is 3. Okay, now we peel off the second outside thing, which is this 3 over here. How do we get rid of that? We divide by 3. Divide by 3. This guy is gone, so we don't need the parentheses anymore. And we have minus 2x plus 8 all over 5 minus 3 equals 1. That's 3 divided by 3. And the problem is just a little smaller. So now how do we undo a minus 3? We add 3 to both sides. And this is now gone. It's been peeled off. We now have negative 2x plus 8 over 5 equals, on the right-hand side of the equal sign, we have 1 plus 3 equals 4. Okay, looking at the left-hand side, the outermost thing now, we have negative 2x plus 8 divided by 5. So that last thing divided by 5 can be undone by timesing by 5. Make sure we do that to both sides of the equation. On the left-hand side, the 5's just cancel. Timesing by 5 and dividing by 5 just undo each other. So we get negative 2x plus 8 equals 4 times 5 is 20. Oh good, look, the problem is starting to get down to a manageable size. How do we undo a plus 8 on the left-hand side? We undo it with a minus 8. So we subtract 8 from both sides, and on the left-hand side it cancels. Plus 8 and minus 8 go away, and so we are left with negative 2x. And on the right-hand side we have 20 minus 8 is 12. And now we only have one thing left near the x, and that is this negative 2 that is multiplying it. So we divide by a negative 2, divide by a negative 2, and on the left-hand side it cancels, leaving us with only the x. 12 divided by a negative 2 is negative 6. Let's double check our answer. And we get x equals negative 6. Number 3. Oh, good. We have some problems that are a little more manageable. Number 3, we have negative 17 minus 7m equals negative 18. Here's the m that we're trying to get by itself right there. So we have two numbers that we have to get rid of. Let's get rid of the negative 17 by adding 17 to both sides of the equation. And we're left with negative 7m, because the negative 17's on the left-hand side canceled, equals negative 18 plus 17. That's a negative 1. Now, how do we get the rest of this? Well, we look at what is next to m. Well, a negative 7 is. Is it added? Nope, it's multiplied. How do we undo multiplication? With division. So we divide by a negative 7, divide by a negative 7, and we are left with m on the left-hand side equals positive 1/7. You could put that in your calculator if you choose to. Let's check our answer. M equals 1/7. All right, number 4. Let's get a little bit of space here. There we go. So we're trying to solve and get t by itself. So we have to get rid of the 3/7 and the plus 1. So let's get rid of the plus 1 with a minus 1. Minus 1 on both sides. Some of you may wonder, why don't we try getting rid of the 3/7 first? By order of operations, this 3/7 and the t are timesing as the first thing that happens. So then the plus 1 comes after. So we always go in reverse order in algebra. We undo what has been done. So we get rid of the addition and subtraction first. So subtract 1, and we are left with 3/7 t equals, because the plus 1 and the minus 1 are now gone, they added to 0. Negative 11 minus 1 is a negative 12. That's a good thing to remember, that it's a negative 12. It's not a 10. Those are both negatives in the same direction. Then 3/7 times t, how do we undo multiplying by 3/7? Well, we divide by 3/7. Dividing by 3/7 and timesing by 7/3 are the same thing. So when we divide by 3/7 on the left-hand side, it's gone, and we're left with t equals, and on the right-hand side we have negative 12 divided by 3/7, or written as times by 7/3. That negative 12 is a negative 12 over 1, and what happens with that? The 12 divided by 3 is 4, and 4 times 7 is 28. Or if you wanted to, you could stick that in your calculator as well, and we get negative 28. Don't forget, a negative times a positive is a negative. And check our answer on that one. T equals negative 28, correct. Number 5. 9 equals 3x plus 17. We have a 3 and a 17 that are on the same side as the x, so let's get rid of them. And we get rid of the addition and subtraction first. So we subtract 17, The 17's on the right-hand side cancel. 9 minus 17 is negative 8 equals 3x. And now we can divide by 3 on both sides, and we are left with x equals negative 8/3. Let's double check our answer. X equals negative 8/3, correct. Number 6, a little bit bigger problem here. 5x plus 7 divided by 4 equals 13. We have three numbers that we're going to have to get rid of, the 5 and the 7 and the 4. Going reverse, it was 5 times x plus 7, then all divided by 4. So let's times by the 4 and get rid of that first. The 4 on the left-hand side, the two 4's just cancel each other. So we have 5x plus 7 equals 13 times 4 is 52. Now, if we've got to get rid of that plus 7, what's the opposite of plus 7? Subtract 7. So we're left with 5x on the left-hand side, because the plus 7 and the minus 7 go away. 52 minus 7 is 45. Good. Now, how do we get rid of this timesing by 5? We divide by 5. And we're left with x equals 9. Good. Let's check our answer on that one. X equals 9. Number 7. Looks like we've got a little bit of simplifying to do here. There are a bunch of t's, so let's put all these t's together. 8t plus 3t is 11t plus 14t. That's 25t minus 17 equals a negative 17. Well, now we've got them together, we can undo and peel stuff off. How do we undo a minus 17? With a plus 17. Plus 17. Great. Cancel those, and it becomes a 0, so we get 25t on the left-hand side equals 0 on the right-hand side. And now, how do we get rid of that multiplying by 25? We divide by 25. So we're left with t equals 0 divided by 25 is just 0. Let's check our answer. T equals 0. Good. And number 8. Oh, this is one of those big ones that we're just going to peel off again. So let's read it in order. If we're trying to get x by itself, right there in the middle, x first times is the 5, then adds the 8. Then that result divides by 2, that result plus 9, all of that times is by the 7, then subtracts the 3. So let's go in reverse order, and opposite of subtracting 3 is adding 3 to both sides. So that will give us 7 parentheses 5x plus 8 all over 2 plus 9. The minus 3 and the plus 3 on that left-hand side of the equation go away, and 18 plus 3 on the right-hand side of the equation is now a 21. Good. How do we undo that times by 7 over here? That was the second to last one that happened to the x. So we divide by 7. Divide by 7. Divide by 7. And those 7's on the left-hand side now cancel, which means we don't need those parentheses anymore. 5x plus 8 over 2 plus 9 all equals what's 21 divided by 7? That's a 3. Good. Now, it looks like this plus 9 is what will go away. Subtract 9, subtract 9. We just ask what's the opposite of adding 9, and it's minus 9. So that cancels there, and we're left with 5x plus 8 divided by 2 equals 3 minus 9 is a negative 6. Oh, negatives have entered the picture. We need to be careful. Okay, so 5x plus 8 divided by 2, well, we have to undo the division by 2 by multiplying by 2 on both sides. And we are left with, let me see, the 2 times and the 2 divided by 2 cancel, divide out to 1, and so they're gone on the left-hand side of the equation, and we're left with, let's write it over here, 5x plus 8 equals, and we have a negative 12, it looks like. Good. Now how can we get rid of the next one? Let me see, the next one is a plus 8. So we minus 8, and we get, with those two gone, the 8's on the left-hand side, we get a 5x, and then that will equal negative 12 minus 8 is a negative 20. And we only have one step left. Let's divide off that 5, divide the 5 on the left-hand side, that cancels, and we get x equals negative 4. Let's double check that answer. Number 8, x equals negative 4. Oh, good. That was a good review of what we did in exercises part A. And you should start to feel this ability. If you want something gone, you do the opposite of it to both sides. And it's just one step at a time to create these large problems into much smaller ones that are more manageable. Good.